So I just wanted to thank everyone for taking time out of your schedule today to hang out with us for 30 minutes. I'm Scott Foerster, product manager on the Pivotal Concourse team.
And I'm Taylor. I'm an engineer on the Pivotal Concourse team.
So we've called our talk Concourse 102. The aim of this talk today is to perform a deeper dive in the underlying mechanics of how Concourse works. Peek under the hood, if you will. It's our assumption that you know what Concourse is already. You can probably create pipelines with the Fly CLI. You've interacted and are familiar with the web UI. You've probably been stuck in situations where you've needed to scale your workers or even submitted issues or PRs to the Concourse repo. And if not, well, you're stuck with us for 30 minutes today. But it'll be great. While we hope this talk is informative for everyone, what we're going to discuss today will probably resonate most with engineers using or operating Concourses and that are planning to use Concourse at scale and will find themselves in situations where understanding the mechanics behind Concourse are essential. So before we get going, we just wanted to do a quick agenda before we dive into things. We're going to start by giving a brief overview of what Concourse is. Then we're going to spend the bulk of our time performing a comprehensive overview of the two main components of Concourse, the web and the worker. Finally, we'll give some tips and best practices around monitoring Concourse, and I put a question mark under questions. We hope there's time for questions, but probably not, so we're going to loiter in the hallway after this if anyone wants to talk to us. Happy to chat for a little bit. So with that housekeeping out of the way, let's dive into things. Okay, so we'd like to preface this talk by letting you know that we don't have enough time to talk about everything. Plenty of details here have been left out for the sake of time and to keep things simple. Everything is important, but we had to prioritize. At this time, I'd also like to mention that although a lot of the concepts we're talking about today can be applied to earlier versions of Concourse, our talk is going to be based around the latest OSS version, version 5.50. Oops, the wrong one. So let's get started. What is Concourse? If you go to the Concourse CI homepage, you'll probably see Concourse described as an open source continuous thing doer. While this description is completely valid, it may be a wee bit of an oversimplification. To most users, Concourse looks a lot like the image on the screen. A series of resources, tasks, and jobs created via YAML files that are sequenced together to create pipelines for automation. The components that make up pipelines are configured through the Fly CLI and visualized through the web UI seen above. Well, because of the nature of this talk, we won't be getting into what resources, tasks, and jobs are. We assume you know what those are already. It is important to emphasize that Concourse is container first. Everything in Concourse runs in containers, ensuring a clean environment on every run. Concourse consists of three main components: the web node, the worker, and the Postgres database. Given that Concourse is stateless in nature, you can spin up as many web nodes and workers as you want because state is kept within the database. As I mentioned before, this talk is not going to be focused on why are my tasks failing and why are my pipelines red. Those are issues specific to your pipeline, and today we want to talk about how your pipeline is being run by Concourse. And these are the components you'll need to know to understand how this works. So before we begin, I wanted to take a quick bird's eye view into the web node and the worker, since they will take up the meat of this talk today. The web node is the brain of Concourse, and it consists of everything you see here in the diagram above, as well as the TSA. We'll be diving further into all these concepts in the coming slides, but I just wanted to give a quick bird's eye view first. The web node is the thing that ensures all your pipelines are running and cleans up the workers. The web node also serves the web UI and the API. I'd also like to draw special attention to the TSA. The TSA essentially controls communication between the web node and the worker using SSH. Simple. Let's also do a brief overview of what the worker is. The worker consists of garden, baggage claim, beacon, and a volume and container sweeper. At the highest level, the worker is where container orchestration is managed. So with all of that out of the way and this preamble being finished, I'm going to hand things over to Taylor to give a more detailed walkthrough of these concepts.
Thanks, Scott. All right, so we're going to take a little walk through a pipeline. And so to help explain some parts of Concourse, we're going to use the first part of this pipeline here. Specifically, we're going to take a look at the first job in detail to help explain certain parts of Concourse. We're also going to think a little bit about the resources. And eventually we'll move on from this pipeline to discuss some of the other remaining components that we're not able to explain just by looking at this pipeline. So the first question we'd like to answer is, what happens when you set a pipeline? You're in your terminal, you do fly-t, your target, set pipeline, and what starts happening on Concourse? Well, when you first create your pipeline, it's actually paused. So at this point, Concourse isn't going to commit any resources to your pipeline. No containers get created, no volumes are created, and once the pipeline is actually unpaused, this will never be the case again. There will always be some artifacts lying around. But for now, you've just created your pipeline, set it for the first time, it's paused. So let's unpause it and ask what happens when you unpause your pipeline. So once your pipeline is unpaused, this routine called the pipeline syncer will actually notice your pipeline, and it's going to create another web routine. And this is happening in the web node. So the pipeline syncer sees your pipeline, sees it's unpaused, and it creates a pipeline routine. And there's always one pipeline routine for each pipeline that exists in your concourse. So if your concourse has 10 pipelines, then there are 10 pipeline routines running on your web node. And the pipeline routine is made up of two subroutines, radar and scheduler. And it's essentially the job of the pipeline routine to manage these two subroutines. So we'll talk about radar first, because nothing happens in your pipeline if radar never runs. So radar's job is to check for new versions of every resource in your pipeline. And it does this by creating a scanner routine. And it creates a scanner routine for each resource configuration in your pipeline. So one resource configuration in your pipeline is equal to one scanner that radar creates. So how many resource configurations do we have in that sample pipeline that we showed earlier? So here's the configuration of it. You don't need to try and read it, but just looking at this, we can figure out how many resource configurations there are. So a resource configuration is anything that falls under the resources and resource types sections in your pipeline configuration. So we can see here that we have 4 items under resources and a 5th item under resource types. So our pipeline has 5 resource configurations. So therefore, radar is going to start 5 scanner routines. One scanner routine for each resource configuration. Now, what is the scanner doing? We have a bunch of scanner routines started. What are they going to do? So the scanner is going to create a check container on each worker. So how are these check containers made now? So the scanner is going to create a check container by first creating volumes. The scanner routine does this by talking to baggage claim. And each check container is going to consist of one resource type volume and one container volume. So we have 2 volumes right now, one resource type volume and one container volume. Now, where did these volumes come from? Because they don't just magically appear on our worker. Our worker has to get them from somewhere. So the container volumes come from the worker's file system. So container volumes come based on the worker's file system. So that those will contain files like the CA certificates. That's what's going to be in these container volumes. And the resource type volumes come from 2 places. Some come bundled with the Concourse binary. So these are volumes based off of the base resource types that come with Concourse. And then others are downloaded either from Docker Hub or from an external image registry. These are typically the volumes that would come from the resource type section. All right, but now back to our check containers. So we have those 2 volumes made. We know where they came from. And now Scanner can tell Garden to create a container based off those 2 volumes that we have. Or sorry, 3 now actually, because we have 2 containers, 1 resource. So Scanner talks to Garden, tells it to create that container, and we create that 1 check container. So now Scanner is going to repeat this process until we have a bunch of volumes and containers. So remember, we had 5 scanner routines running, therefore we end up with 5 check containers and a similar multiple of volumes for each of those containers. Now, how long do our check containers exist for? So check containers exist for 1 hour. And after 1 hour, they are then deleted and recreated. So why do check containers exist for 1 hour? So there are 2 reasons that they stay around for only 1 hour, or why Concourse doesn't delete them right away after creating them and using them. The first reason is that resources are by default checked every minute. So Concourse doesn't want to waste time every minute having to go through this container creation process. So Concourse will create the check container once, and it'll leave it around for an hour, so that way you can just continue to reuse it over the hour. And the second reason that a check container lasts only 1 hour is so one worker doesn't get overloaded with having all these check containers persisted on it for forever. So the 1 hour lifetime gives Concourse a chance to every so often rebalance the check containers across the workers based on whatever their current state may be. And one last thing about check containers that's important to note is that check containers are essentially your minimum workload. So when you have your pipelines all unpaused, and even if no job is running, the check containers themselves are always running. So check containers become your minimum workload across your Concourse cluster. All right, back to our sample pipeline. So our check containers are created, they ran, and we found some new versions from these. So what happens next now that we have these new versions? So the scheduler starts up. The scheduler was actually always running, and the scheduler, again, is another routine that's running in the web node. But the scheduler had nothing to do previously when there are no versions. So it only has stuff to do once there are new versions that have been discovered. So let's say that a new version was found by our app resource. And our app resource is just checking a GitHub repo, looking for new commits. And every time there's a new commit, that becomes a new version in Concourse. So we found a new version, and that means scheduler can now queue up a build for our first test job there, since now there's a valid input for it. And the scheduler does this by starting a build routine. And again, this is a build routine just on the web node. So a build routine is what actually runs your job. It looks at your job plan, and it executes each step in your job plan. And it does this by creating containers and volumes, similar to the scanner. And the build routine is what's monitoring the entire run of whatever build it was told to run. And it's logging all that output that the job is generating and putting that into the database. So that's its main job. So let's find out how a build routine executes a job. So the build routine will see that our job has 2 steps. And up here on the screen, we just have the basic job plan that the build routine would have loaded into memory. So we can see that we have a get step and we have a task step. So these are the 2 steps in our build plan here. And the build routine will start the job by, of course, running the get step first. So the build routine, similar to scanner, is going to talk to baggage claim first and have it create a resource volume. The resource volume is going to be where some of the data from this get step is going to be outputted. So it creates basically an empty resource volume to start. And then the build routine will talk to Garden, and it will have it create a container with that empty resource volume, and it's going to reuse one of the resource type volumes that was used previously by scanner and the check containers. And then a script will be executed inside this get container, and the output will be saved in that empty resource volume, which is now no longer empty. And that's pretty much how the get step is executed. So the output of this specific get step is just a git clone of the repo that was in that resource. So all of our source code and our tests from this Git repo are now in this resource volume. All right, and with that, we're almost done running the job, halfway there. There's only 2 steps in this job. And the last step is the task step. So how is the task step executed? So every task step has its own configuration. So this is the configuration for our task step. So of course, the build routine is going to have to go through this task configuration to know how to run it. So the goal of this specific task is to just run go test. So run some unit tests that we have inside our source code. And the first thing the build routine is going to do is figure out what type of worker platform does this task need to run on, whether it's Linux, Windows, Darwin. It'll find that worker, and then it'll continue going through the task plan here. So next, the build routine will check what container the task should be run in, because you can tell Concourse, run my task in this specific container. So here, we're just using the Golang container image. And again, by default, this will be downloaded from Docker Hub. So yeah, it will be downloaded from Docker Hub, or it can be downloaded from an external, some other image registry as well. An important thing to also note here is it's generally in your interest to try and keep these container images as small as possible. We have seen people make really large 5 GB Docker images, and every time Concourse has to go and download this Docker image, it does cache it, of course, but that means it's taking up disk space on your worker, and every so often the cache will expire or there will be a new image to download, and every time that happens, it means you have to download a large Docker image and save it on your workers. So to keep things speedy and lean, it's generally in your interest to try and keep those Docker images small. All right, so what does our worker look like now after fetching that Docker image for this task? So after downloading the image from Docker Hub there, the worker will now have 2 resource volumes. So it just made a second one based off of that Docker image. So Docker images just become resource volumes on your worker. So now our task step has that container image, and the last thing it needs is its input volumes. So these are volumes that existed from previous steps in your job. So typically these are satisfied by get steps, and they can be satisfied from the output of other tasks as well. But in this case, the only input is the app volume that we want, and that came from the previous get step. So on our worker, that means that the build routine can now talk to Garden and have it create a container using the Docker image volume and the app volume that our source code contains. So it's going to use the 2 resource volumes that we have on that worker here. That first one contains the app source code, and the second one is the file system of the Docker image that came from Docker Hub. So with the container created, the build routine can then run go test inside your container, and the build routine will simply capture the output of whatever that was. And with that, the build routine has finished running the entire job plan. So that's the entire job. Now, if your job was successful, then of course the pipeline will continue running. This process of scheduler, checking what needs to be run, creating build routines simply continues and keeps going over and over again as your entire pipeline runs. And another thing to note about successful jobs is that the garbage collection will actually eventually delete the get and task containers that were created during this job. They don't get immediately deleted, they get deleted a little shortly after. Depends how garbage collector is configured, but we'll get into that a little bit more later on when we talk about garbage collector. All right. And so in general, if your jobs are passing, you should see something like this if you're tracking metrics on your cluster. You'll see as jobs start that you'll see the number of containers and volume slowly increasing on your workers, and then it will probably peak for some time as those jobs run, depending on how long the containers need to be around for until the task is complete, and then as they get garbage collected, you should see them going back down. So overall, this is a sign of a healthy Concourse cluster. Now, what if your job failed? So for failed jobs, Concourse keeps the containers and volumes around. It does not delete them. So if your job fails, the containers and volumes from that job will still be there. So why does Concourse keep the containers and volumes? So Concourse keeps the containers and volumes because Concourse doesn't know when people will be able to debug them. This could have happened on a Friday night or a Saturday morning, and you're probably not going to be checking your jobs or your pipelines on the weekend. At least we hope that you're not. So Concourse will just leave them around, so that way on Monday morning you can come in and you can check and see what happened, why your jobs failed. So that's the main reason why Concourse will keep your containers and volumes around. We don't want there to be any rush to have to look at your pipelines, figure out why they failed before containers start disappearing on you. The containers should never disappear if your job failed. All right, so with this, we're going to leave our example pipeline here with the one job passed, and we're going to talk about some of the remaining components in the web node. And those last few components are the build tracker, the build reaper, and the garbage collector. So first up is the build tracker. So what does the build tracker do? So the build tracker just starts build routines, just like the scheduler. So why do we need the build tracker then if it's doing exactly what the scheduler does? So the scheduler is already creating routines. And the reason we have the build tracker is so it can save any orphan builds. Now, what's an orphan build? So let's say scheduler started a build routine, as it normally does, and it's running our test job, as you can see there. But then something happens, like there's a networking issue, or the entire web node goes down. Like the underlying VM is just gone for some reason. So basically, if something happens where the build routine that was tracking that test job, if it loses connection with that worker, this results in an orphan build, essentially. Because at this point, the build routine that was running would exit. So yeah, now we have a job running on a worker, and there's no build routine attached to it. So this is where the build tracker now comes in. So once whatever issue was resolved, whether it was networking or the web node came down and it finally comes back up, the build tracker is able to start a new build routine. And it does this by looking in the database for any orphan builds, because again, Concourse saves all state in the database. So the build tracker will check the database for any orphan builds, and when it finds one, it'll simply start a new build routine for that job. And just like the build tracker, the build routine can just look in the database to find out where the job was left off. And then everything just continues as normal. So that's pretty much it for the build tracker. It just starts build routines, so that way you never lose whatever was happening on your workers. So the next module that we'll talk about is the build reaper. So the build reaper's job is to delete logs that come from builds. And by default, Concourse actually doesn't delete any builds. Because again, we don't want to delete something that you might want to keep around. So the build reaper does nothing. And if you want to do something, you have to set a build log retention policy. This can be set at the web node level. So when you're deploying Concourse, you can say globally, reap all my logs that are X days old or after X number of builds across all pipelines. So that can be set at the web node level. Users can also have control over their build retention policy. So then they can set it in their task configuration when they create their pipelines. Now, when should you set a build log retention policy? So if you have a job that runs frequently, that's typically a good candidate for something that you'll want to have its build logs reaped every so often. For example, we have a pipeline, or one specific job in a pipeline, that generates about 600 megabytes of log output. And then that all gets saved in the Concourse database. So that's a lot of data to just be saving in the Concourse database itself, because it'll take up a lot of disk space on there. So that's one job where we actually only want to keep the most recent builds. So anything that either generates a lot of output frequently or even just when you run it once, it generates a lot of data in that one shot. Those are both very good reasons for why you'd want to set a build log retention policy. But what if you want to keep all your logs, but you know that the Concourse database is probably not the best place to keep those? What do? So you can configure Concourse to output all its logs to any Syslog endpoint that you can point it to. So if you don't want to save all these like 600 megabyte logs in your Concourse database, you can instead have Concourse just drain all its logs to some Syslog endpoint, and you can save it in some other persistent data location. That'll make much more sense for your logs. And of course, when the build reaper is deleting your logs, this is what you'll end up seeing if you go to a really old build that you don't have the logs for. So here, this is one of the jobs I was talking about that runs really frequently. You can see it's in like the 200,000th build already, and we haven't even had it for that long. And I went and looked at the first one, and it was reaped. So this is what you end up seeing when your logs have been reaped. All right, and the last component that we'll talk about is the garbage collector. And the garbage collector is a two-step process. The first part happens on the web node. So the web node's job in this process is to figure out what containers and volumes can be deleted. And it does this based on this concept of ownership. So every container and volume has owners. And who are these owners? Who can own a container and volume? So ownership can come from running builds, failed jobs, resource caches, and check containers. Those are essentially the main sources of ownership for containers and volumes. And it's generally as things finish, so if your builds are successful, that's when ownership will be released on any containers and volumes that build ran. If a job fails, it retains that ownership. And same thing with check containers. Check containers have that default 1 hour minimum lifetime. And once that 1 hour is up, that's simply a release of ownership. And that's how the web node knows to list those containers as ready to be deleted. The second part of the garbage collection process happens on the worker. So the worker is the one that's responsible for actually deleting what the web node finds out to delete. So the worker will be given a list of containers and volumes to delete, and based on that, the web node tells it to delete it. So what does this look like? The garbage collection process simply reaches out to the TSA server on the web node. TSA is what's used to communicate, and it reports what volumes and containers it currently has to the web node. This information gets saved in the database and is then used by garbage collector to figure out what can be deleted. And then the garbage collector on the web node will save the list of containers and volumes to delete back in the database. And as a response to that initial request from the worker will then delete the containers and volumes. And that's the garbage collection process. I'm going to hand it back to Scott now, who will wrap things up.
Yep. So before we got out of here, I just wanted to briefly touch on monitoring your Concourse, as it's very important. So we strongly suggest setting up monitoring around your Concourse deployments, especially as you scale. In our experience troubleshooting and operating large Concourse deployments, we've seen that as your Concourse grows and you begin to add multiple teams, workers, ATCs, etc., it's no longer good enough to basically judge your KPIs as to whether your pipeline is red or green for overall Concourse health. Selfishly, it also helps us to assist users and customers in troubleshooting when they have relevant metrics present. Within Pivotal, we manage 2 large-scale Concourse as a service deployments for internal pivots. The deployments are called Wings and Hush House. We have monitoring set up on both deployments. Now, we're not saying what we currently measure is perfect, but it should give a pretty good overview about what you could set up for monitoring. For Wings, metrics are consumed via InfluxDB and displayed on a Grafana dashboard. For Hush House, metrics are consumed via Prometheus and displayed on a Grafana dashboard. And we have SLIs and SLOs displayed on monitors through Datadog. We also have alerts and notifications set up to send to our Slack when certain thresholds are crossed. There's no particular reason why we use Influx in one deployment and Prometheus in the other. We just think it gives us good insight into the most common ways users and customers are emitting metrics. Our metrics dashboard is actually currently available publicly, and when you get the link slides to the links, you'll be able to access it there, or the links to the slides, I should say. You should be able to access it. Lots of potential disasters can be preemptively solved by having an appropriate metrics approach. This is something the Concourse team highly suggests investing in as you scale and begin to understand more of the under-the-hood mechanics that we've mentioned here today. So just to close up, thanks so much for coming out. There's a few methods to stay in touch with us. You can check out the Concourse CI website, follow our GitHub repo, post on our Discuss message board, or chat with us on Discord. Once again, the links to these will be available in the slides. All right, thanks so much.